Hi everyone, glad to have you back at the AI Academy. Today, we are diving back into our Business Analytics for Management Decision course. In this class, we will be focusing on understanding decision models, sorting them into different categories or its classification, looking at how they are structured, and we will even explore some real-life examples to help it all make sense. Let's get started today, class, going deep into the knowing decision models. A decision model is a simplified way to represent a real-world system, concept, or object. It captures the most essential and important features of whatever it is modeling. It can take the form of a written description or a verbal explanation. Its purpose is to break down a complex reality into a more manageable representation that focuses on the critical components. This helps in understanding, analyzing, and making decisions about the real system being modeled. It strips away unnecessary details to provide a clear and concise view of the key factors involved. It can be explained in different ways. We can write them down on paper, draw diagrams, or even just talk about them with word. It can be a visual display, a mathematical formula, or a spreadsheet representation. It is like telling a story or giving directions to someone. As long as it helps us to understand how things work and make decisions, it is doing its job. So, in simple terms, a decision model is like a simplified guide that represents a real-life situation, focusing on the important bits, and can be explained in different ways, like writing or talking. Let us discuss on classification of decision model. First, we will start with symbolic models, which represents decision situations using symbols, logical statements, and rules. These models are often used in expert systems or decision support systems. They are based on the knowledge and experience of experts in a particular domain. Let's take an example. In a medical diagnosis system, symbolic models could use rules like, if the patient has symptom A and symptom B, then the possible disease is X. Mathematical models, which represents decision situations using mathematical equations, formulas, or algorithms. These models are useful when the decision problem can be quantified and expressed numerically. To understand more, let's take an example. In a production planning problem, a mathematical model might use linear equations to represent constraints like available resources and demand, with the goal of maximizing profits or minimizing costs. Next is deterministic models. It assumes that all the factors affecting the decision situation are known with certainty. These models do not involve any randomness or uncertainty. Let's take an example. In a transportation problem, where the goal is to minimize the cost of shipping goods from various sources to different destinations, a deterministic model would assume that the costs, supply, and demand are all known with certainty. Then comes stochastic models. It takes into account the presence of random or probabilistic elements in the decision situation. These models incorporate uncertainty or risk in the decision-making process. Example, in a stock market investment problem, a stochastic model might consider the random fluctuations in stock prices and incorporate probabilities to evaluate the potential gains or losses. In simple terms, symbolic models use symbols and rules to represent knowledge. Mathematical models use equations and formulas to represent quantifiable decision problems. Deterministic models assume all factors are known with certainty. Stochastic models account for randomness and uncertainty in the decision situation. The choice of the appropriate decision model depends on the nature of the problem, the available information, and the desired level of accuracy and complexity in the decision-making process. Now, let's us focus on structure of decision model. This image illustrates the basic structure and flow of a decision model. A decision model is a tool used to analyze and support decision-making processes. The above image is divided into three main components. They are input, decision model, and then come output. Inputs represent the various types of information or variables that serve as inputs to the decision model. It includes data, uncontrollable variable, and decision variable. Data refers to relevant facts, figures, or information related to the decision situation. Uncontrollable variables are the factors that cannot be directly influenced or controlled but may impact the decision. Decision variables are the variables or choices that the decision maker can control or adjust to influence the desired outcome. After input, there is decision model, which is the central component that represents the decision model itself, which takes in the inputs like data, uncontrollable variables, and decision variables and processes them using various techniques, algorithms, or methodologies. Outputs shows the types of outputs generated by the decision model, which are designed to aid in the decision-making process. The outputs can be measures of performance like metrics, indicators, or evaluations that help assess the potential performance or effectiveness of a particular decision or course of action. Measures of behavior, the outputs provide insights into how different stakeholders, example, customers, employees, suppliers might behave or react to the proposed decision or action. The arrows in the image demonstrate the flow of information. The inputs like data, uncontrollable variables, and decision variables are fed into the decision model, which then processes and analyzes these inputs to produce the outputs like measures of performance or behavior. By using a decision model, decision makers can systematically evaluate various alternatives, consider relevant factors, and obtain quantitative or qualitative measures to support their decision-making process more effectively. Now, let us discuss some real-life example of decision model. Let us take an example of a decision model which is used to represent the sales pattern of a new product, such as the first-generation iPad or a 3D television. The example shows three forms of the model. Descriptive form, which describes the pattern of sales for a new product in words. It says that the sales might grow at an increasing rate over time as positive customer feedback spreads. This pattern is often represented by an S-shaped curve. Graphical form, which is the S-shaped curve mentioned in the descriptive form, is the graphical representation of the sales pattern. It shows how the sales start slowly, then increase rapidly as the product gains popularity, and finally level off as the market becomes saturated. Mathematical form, which is a form of the model, is an equation that represents the S-shaped curve. The equation given in the example is S equals to AE to the power of B, which is to the power of CT. In this equation, S represents the sales. T represents time. E is the base of natural logarithms, is which approximately 2.718. A, B, and C are constants that determine the shape and scale of the curve. By plugging in different values for the constants A, B, and C, the equation can be adjusted to fit the actual sales data for a particular product. The mathematical form of the model allows businesses to make predictions and analyze the sales pattern more precisely. It can help them make informed decisions about production, inventory, marketing, and other aspects of the product lifecycle. Let us continue further by taking an example. Imagine we are running a business, and we have to make important decisions every day. Sometimes, it can be challenging to figure out the best course of action, especially when there are many factors to consider. That's where a decision model comes in handy. It's like a tool that helps us to understand and analyze the situation better, so we can make the right decisions. Now, let's talk about the types of inputs that go into a decision model. First, we have data. This is basically the information or facts that are relevant to the decision we are trying to make. It could be things like sales figures, customer preferences, or market trends. Next, we have uncontrollable variables. These are the factors that cannot directly control or change, but they still impact our decision. For example, the economic conditions, government regulations, or the actions of the competitors. Finally, we have decision variables or controllable variables. These are the elements that we can directly control or adjust to influence the outcome. For instance, the price of the product, the marketing budget, or the number of employees hired. Now, let's talk about the types of outputs that a decision model can provide. One of the main outputs is performance measures. These are metrics or indicators that help us to evaluate how well the decision is performing. It could be something like profit, customer satisfaction, or market share. Another type of output is behavioral measures. These give us insights into how the decision might affect the behavior of different stakeholders, such as customers, employees, or suppliers. So, in simple terms, a decision model takes in various inputs like data, uncontrollable variables, and decision variables and processes them to provide outputs like performance measures and behavioral measures. These outputs can then help to make better informed decisions that align with the goals and objectives. Remember, a decision model is just a tool to aid the decision-making process. It does not replace the judgment or expertise, it simply provides us with valuable insights and analysis to support our decisions. Let's take a real-time example: grocery store sales promotion model. In context, imagine a manager at a local grocery store facing stiff competition and fluctuating customer demands. We want to maximize sales by employing effective pricing, coupon, and advertising strategies. In objective, the goal is to develop a data-driven decision model using business analytics to predict the impact of different sales promotion strategies on overall sales. Data collection like historical sales data, which gather data on past sales figures, including daily, weekly, and seasonal trends. Pricing data, which collect information on pricing strategies employed during different time periods. Coupon usage data, it records data on coupon distributions and redemptions. Advertising expenditure, which track advertising spend and its corresponding impact on sales. Next is model development. Under it comes feature engineering, which combine and pre-process the collected data to create meaningful features such as average daily sales, coupon redemption rates, and advertising effectiveness. Model selection chooses appropriate machine learning algorithms such as regression or decision trees to build the predictive model. Training and validation, it trains the model on historical data while validating its accuracy using cross-validation techniques. Fine-tuning, which adjust model parameters to improve performance and generalization. Now comes model deployment. Real-time data integration, which implement mechanisms to continuously feed real-time data into the model for ongoing analysis. Decision support system integrates the model into a decision support system accessible to store managers. Scenario analysis allow managers to simulate various promotion scenarios and visualize their potential impact on sales. Decision-making, which includes optimal pricing strategy that uses the model to determine the most effective pricing strategy for different products and customer segments. Coupon allocation allocates coupons based on predicted customer behavior to maximize redemption rates and sales uplift. Advertising allocation allocates advertising budget across different channels, example, digital, print, based on predicted ROI. Dynamic adjustments continuously monitor sales performance and adjust promotion strategies in real time based on emerging trends and insights from the model. Finally, evaluation and iteration. In performance monitoring, regularly evaluate the model's performance against actual sales data and refine it as needed. Feedback loop, solicit feedback from store managers and stakeholders to identify areas for improvement and iterate on the decision model. Continuous learning, incorporate new data and insights into the model to ensure its relevance and effectiveness over time. By leveraging this sales promotion model, the grocery store can make informed decisions to optimize sales performance and stay competitive in the market. Let's discuss on descriptive decision models with the help of diagram. This image represents an influence diagram, which is a visual tool used in descriptive decision models. Influence diagrams depict the relationships between different elements or factors involved in a decision-making scenario. In this specific example, the influence diagram illustrates the factors that contribute to the total cost. The diagram consists of three nodes like total cost, fixed cost, and variable cost. Total cost is the central node, representing the overall or cumulative cost that results from the influence of other factors. Fixed cost represents the costs that remain constant or fixed, regardless of other variables or changes in the decision-making process. Variable cost represents the costs that can vary or fluctuate based on different factors or decisions made. The arrows in the diagram indicate the directional influence or impact that the fixed cost and variable cost nodes have on the total cost node. In other words, both the fixed cost and the variable cost contribute to and influence the determination of the total cost. This diagram visually shows how the various elements like fixed cost and variable cost relate to one another and ultimately influence the total cost. It provides a simplified representation of the relationships and dependencies between these factors within the decision-making context. It is important to note that influence diagrams are descriptive models that aim to capture and represent the problem visually. They do not prescribe specific actions or decisions but rather provide a framework for understanding the relationships and dependencies within the problem domain. Let us conclude today's lecture by discussing on this topic on decision model. Predictive decision models are tools used to help managers analyze potential risks and make informed decisions about the future. These models incorporate uncertainty, which means they acknowledge that we do not have perfect knowledge about what will happen in the future. The goal of predictive decision models is to predict or forecast what is likely to happen in the future based on the available information and data. By considering the uncertainties involved, these models can help managers understand the potential risks associated with different outcomes or scenarios. Uncertainty in this context refers to the lack of complete or perfect information about future events or circumstances. We may have estimates, probabilities, or assumptions, but there is always some level of uncertainty about what will actually happen. Risk, on the other hand, is associated with the potential consequences or outcomes that may occur due to the uncertainties involved. It's about the potential for loss, harm, or negative impact that could result from the actual events or circumstances that unfold in the future. For example, let's say a company is considering launching a new product. A predictive decision model could be used to forecast the potential demand for the product, taking into account factors such as market trends, consumer preferences, and economic conditions. However, there would be inherent uncertainties in these factors, and the model would need to incorporate those uncertainties to provide a range of possible outcomes or scenarios. By analyzing the potential risks associated with each scenario, such as the risk of low demand or high production costs, managers can make more informed decisions about whether to proceed with the product launch, adjust their strategy, or explore alternative options. It helps managers navigate uncertainty by providing insights into potential future outcomes and the associated risks, allowing them to make more informed and proactive decisions rather than relying solely on guesswork or assumptions. They are tools that help decision-makers identify the best possible solution or course of action. These models are focused on finding the optimal solution among various alternatives, taking into account certain objectives and constraints. The process of finding the best solution is called optimization. Optimization involves determining the values of certain decision variables that either minimize or maximize a specific quantity of interest, such as cost or profit. The equation or formula that represents the quantity to be minimized or maximized is called the objective function. For example, if a company wants to minimize its production costs, the objective function would express the total cost as a mathematical equation involving different variables, such as material costs, labor costs, and overhead expenses. However, the optimization process is not completely open-ended. There are usually limitations or restrictions that must be considered, known as constraints. Constraints can be related to factors such as available resources, production capacities, legal regulations, or any other relevant limitations that must be respected. The optimal solution is the set of values for the decision variables that results in the minimum or maximum value of the objective function while satisfying all the specified constraints. In other words, it is the best possible solution that meets the desired objective while adhering to the given limitations or restrictions. For instance, In the case of minimizing production costs, the optimal solution would be the combination of input values, example raw material quantities, labor hours, that results in the lowest possible total cost while adhering to constraints like available budget, production capacity, or quality standards. Prescriptive decision models, through optimization techniques, help decision-makers systematically explore different alternatives and identify the best solution that optimizes the desired outcome, considering the relevant objectives and constraints. In summary, this lecture covered the following topics such as knowing decision models, its classification, structure, and also we explored some real-life examples. We hope you liked this course. If you did, please give it thumbs up and subscribe to our channel. Your support means a lot and motivates us to create more educational content on business analytics for management decision-making. In the next lecture we will discuss on knowing the steps of problem-solving and decision-making, understanding to interpret results and making decision, and many more. Get ready for the next lecture on business analytics for management decision-making. Thanks for watching, and we will see you next time.